bringing AI out of the lab and into the hands of medical professionals. By Brian Rogers, NeuroThink.
Hello, everybody. Thanks for having me here in Malta, beautiful island. This is my first time here, so coming from the United States. You saw Charles here, COO with my company, partner in the business. So I am going to talk a little bit today about how AI can come into with medical professionals outside the lab. So before I start talking about AI and why and how it's going to be more accessible, I wanted to also first start talking about brain science. So being human is very different than being a machine right now. So turns out our brains are actually really amazing machines. This 3-pound blob of 86 billion neurons, 100 trillion connections. For my knowledge of computers, I don't know if there's a computer out there today that has 100 trillion connections. So, in fact, a couple scientists, one from Google, one from Harvard, did a study. They took a little sample of the brain, 1 millimeter in cubic size, and it consisted of 30,000 cells, 130 million connections, and this accounted for, remember it was 1 cubic millimeter, so tiny. It accounted for about 1.4 petabytes, petabytes of data, which is about 20,000 times the size of the Library of Congress in the United States. So what is it really about being human? How is it so different? One of the biggest things about being a human that's so different is we have subjective experience, or we have consciousness. So this is very different than a machine. A machine is definitely getting more intelligent, but it is not establishing being. It doesn't have that sense of conscious or signals of senses. It's more about predictive modeling, and you need to feed it data to make it smarter. As a human being, we are fed senses, we're fed our past experiences to be who we are and establish our consciousness. And for those in the audience that are in neuroscience, you probably also know that really the study of self-awareness or consciousness is really still kind of confusing. We don't quite know exactly what consciousness is in the human being. So there's a scientist at Sussex University, Dr. Clark. He believes this is a form of controlled hallucinations. So we build these models and these intersection of senses and experiences that really help us define who we are and our consciousness. Again, something very different than computers, something a computer may not have ever. It's possible maybe in the future, but from what I've learned about computer science and where we are with computers now, and I'd like to say that I'm pretty futuristic thinking about computers. I don't see it getting to this point for a very long time, maybe not in my lifetime. So let's do a little experiment. When you see this picture, a lot of your reactions in the audience may be, it's a cat. Or some of the expressions in the audience may be, wow, it's such a cute kitty. This cute kitty sitting in a fluffy bed, sound asleep. So this is another thing that's really different than a computer. A computer has the ability to classify based on physical attributes. So it's very easy for the computer to say, that's a cat. But when you're talking about more of that functional connection, this is something that us humans do that is not possible with computers. So ad hoc category construction, as they say in neuroscience. So what is AI and what's ML? Basically, AI is just mimicking biology, human biology in the brain. And it's really, in reality, it's a loose connection. From all the things I said about the brain, you can tell the brain is way more advanced than any computer out there. So to teach AI, you've got to use ML. And so machine learning is really just a way of feeding a lot of data into a model and teaching it over and over and over, giving it, and in most cases, giving it an answer. And then you see how the computer reacts or the model reacts with this model over and over until you get the right answer, and then you can use that trained model to inference in the future. So a neural network is very much like the brain from a standpoint of this mimicking science, lighting up neurons, same thing with a deep neural network. So I'll unpack this slide. I know it's kind of complex, and members of my team were like, Brian, you can't bring this slide up because it's too complex. So I'll try to make it very simple here. So essentially, if you want to teach a computer to identify me, you need to give it lots of pictures of human faces, my face, give it that input, and then you go through and you give it an answer. So this answer, that's who I am. And then along the way, you go through and adjust each one of these what's called hidden layers, and these dots are these synthetic neurons, and you're giving these each mathematical weights through the network. This is a very simplistic representation. Something like GPT-3 has over 1 billion, maybe 2 billion parameters. Very difficult to understand exactly how the computer got there, but some of these advanced models can get really good at the output. So one of the things that I want to talk about was what's currently happening that I think is exciting in medicine. And this is the ability to use computer vision in brain imaging. So for starters here, from these previous talks, I don't believe that the doctor will be replaced. I think it's really important that the doctor stays in the loop. But so if you look at the accuracy of some of these models. So in this model here, it was on breast cancer at NYU Langone and Perlmutter in New York City. So they took almost 45,000 already completed ultrasounds, and they found that the computer vision had a 37% improvement and 27% reduction in the number of samples required. May not sound like a huge number, but this is getting better and better every year as more and more compute power is available and different methodologies of deep neural networks. So it will eventually get to the point where a doctor really will be able to confidently rely on some of the predictions that are made by these models. So this is not just me subjectively saying, the doctor needs to be involved. We actually went out and partnered with Moffitt Cancer Center down in Tampa. And what we did down in Moffitt Cancer Center was to understand what are they doing to win the confidence of the doctors. So we worked with two doctors, Dr. �W𝐞𝐝 and Dr. Liu, and they walked us through their whole methodology. One thing that's really cool about Moffitt is one of the only hospitals in the United States that actually has a machine learning department. So these guys are actually data scientists. And so they're tasked with going out and working with doctors. And what they found was, at first, doctors were a little suspect about this and said, I'm not quite sure about this whole AI thing. And what they did to win that confidence or to win the trust of the medical professionals was to go to them with asking for the variables. So oftentimes these models will come up with known or unknown variables, and then getting the human in the loop or the doctor in the loop, the doctor then was able to look at variables that could be replaced or brought into the model. So at Neurothick, what we did, we're always trying to explore how we could use our platform to help different industries out. We see the medical field as a huge opportunity because of all the things I just said. And so with this thing that we did here, we did a study, or actually built a small app for Moffitt and presented to them. where we had a tablet where a medical professional could go and annotate. So again, as I said earlier, it's all about first giving the model the answer. So the radiologist has to go use the tablet and annotate where they see areas of interest or problems. And that's helping the model train. So the model will go into, oh, I'm short in time here. The model will be fed into the system, large database. From that large database, it creates an inference. And what an inference is basically, the model will be trained at a level of accuracy that the doctors feel is sufficient. Once that model is trained, it can be then sent out all around the world. So let's say it's a small hospital in an African country. They can use this on a scan, and it will be just as good as anything out of New York City because it was trained by these different professionals around the world. So real quick, I'll wrap up here. Some of the things I see in the future here with machine learning and AI, I do think it's going to get a lot better. I think it's going to be, what's going to make AI great is the ability to get more people to interact with it. I think that in the future, it's not going to be just data scientists or programmers to do this. We're already building a platform that's what we call radically accessible because we're building tools and a graphic user interface that's making it very easy for people that are non-technical to come in and build these models. So as the compute resource starts to increase, we provide a better user interface and new techniques. And even you could get to a point where you just talk to it and it will do it for you. This is where I see things going. So guys, thanks a lot. Sorry for going a little over time here, but appreciate your time today. Thanks.